For this question, we are asked to design 3 to 8 decoder using multiple 2 to 4 decoders. We're not going to start with simplification of the question. The first step is going to be to verify the number of inputs, number of outputs. Then we have to find the number of minterms and respectively create the truth table. The first part of our work is almost done because the question specifies that we need to decode 3 input, so 3-digit code, into an 8 output, which means into an 8-digit code. So this one means that we already know the answer to step 1. We do know the answer to step 2. So what is left for us to do is create a truth table and figure out a way to simplify the function. Using the 3 inputs and the 3 outputs, labeling them respectively S0, S1, S2 for the inputs, and from Q0 to Q7 for the outputs, we know that we're dealing with 2 to the power of 3, so it's going to be 8 different combinations of the zeros and ones, and we organize this one into the columns for S0, S1, and S2, as we usually do. For the outputs, key 0 to key 7, we have to make sure that because this is a decoder, the main diagonal into the output matrix part of the truth table will have to be all along ones, and all the other values are going to be 0. And this is exactly how we fill in our table. What also we can recognize from here is the expression for each minterm, making sure that we take the proper true or complement value for S0, S1, S2 for each minterm. The next step is going to be to find a way to use the 2 to 4 decoders instead of directly one big decoder that transforms 3 inputs to 8 outputs. The logic in here has to be based on the number of inputs and outputs being the same. The 2 to 4 decoder is going to give us 4 outputs, so if we use 2 of them, we're going to end up on 8 outputs, which is good. But the 2 to 4 decoder is, each one of them is using 2 inputs. I'm currently having 3 inputs. I could use a common input S0 and S1 and play with the combination within. There will be no problem in here. But S2 will remain an additional signal, which I will not know at this stage what to do. In order to figure out, we will have to concentrate on any pattern, any relation we see in the truth table looking into the column for S2. If you look carefully in there, you could realize that S2 changes values from 0 to 1 into 2 groups of 4. So 4 zeros are followed with 4 ones. If we divide this table into 2, we will be able to figure out that there is one complete table in here which defines a 2 to 4 decoder, and there is another table in here which also defines a 2 to 4 decoder. So all we have to figure out is how to type up S2 with those 2 to 4 decoders. Apparently, if we use as input signals in the first block S0 and S1, we're going to have outputs from Q0 till Q3, and this decoder is going to be activated if S2 takes a value of 0. So I could call S2 enabling signal and give it the option to change the values from 0 to 1. I could use inverter in here. Now let's see if using inverter is going to help me with the second block down. A second block will take as outputs Q4, Q5, Q6, and Q7, which will have as inputs the S0 and S1 again, but this time they will have to be activated by a value of 1 for the enabling signal S2, which basically solves the problem. So we are going to end up on 3 inputs, S0 and S1 actually changing the values, giving the input signals to the 2 different decoders, 2 to 4 decoders, and S2 is going to serve as a normal enabling signal. So let's draw what we just said. We said that if S2 signal is changed to enabling signal, we will have 2 inputs, S0 and S1, which will work with particular outputs for 2 different 2 to 4 decoders. And as we said already, the division is the moment when we have the enabling signal being switched between 0 and 1. Taking the 2 parts one step at a time, we're going to concentrate first on the upper part, where we have S0 and S1 being input signals, and Q0, Q1, Q2, and Q3 being the output signals for the first 2 to 4 decoder, which will be enabled when the enabling signal S2 takes the value of 0. Considering this, we can actually draw the decoder, and what I would like before going to the drawing of the decoder actually is organize my minterms considering the 3 input signals right now. Don't forget, we said we're using S0, S1, and S2 in here. We do not have any changes in the combinations for S0 and S1. The only additional one we're going to add in here is signal S2, which we called EN, enabling signal. And for that particular decoder, for the first decoder, which we noted in blue, it's going to have a value of 0. Now let's look into the second half of the table. It uses exactly the same S0 and S1 as input signals. It repeats the same combinations, and it has Q4, Q5, Q6, and Q7 as output signals. So the only difference between the first 2 to 4 decoder and this one is that the second one, the one I'm looking at right now, the red one, is going to be activated if the enabling signal takes the value of 1. Which means at this stage I could rewrite one more time the minterms, concentrating on the expressions for Q4, Q5, Q6, and Q7, considering that the value of the enabling signal is 1. And here is what I got. From here, I could go to the logic diagram, and I will draw the 2 decoders, 2 to 4 decoders, and I will carefully tie them up with the input signals S0, S1, and S2, which we already call EN, enabling signal. So the first of my 2 to 4 decoders is ready. This is the one which takes the minterms M7, M6, M5, and M4. It has the 4 outputs, Q4, Q5, Q6, Q7. It uses the 2 inputs, S0 and S1, and it has the additional third signal, the input signal, which we called enabling signal. Under the circumstances, at the moment, the enabling signal is going to activate that decoder when the value is equal to 1. Now, very gently, step by step, we're going to add in here the second part for the blue decoder, which takes the minterms M3, M2, M1, and M0, and it is going to take from the branches for S0 and S1, the signals, the input signals S0 and S1, and it will also use the enabling signal, and from there we will have to attach one inverter, so we are going to have the opposite value of whatever En was initially. So let's do that one step at a time. We will organize another input from S0, another input from S1, and respectively from the enabling signal we're going to attach to it one inverter, and then the three of them will become the two inputs for the second 2 to 4 converter, and the blue one remains enabling signal. Now let's try to organize the outputs, and we will tie them up with the respective minterms. My logic diagram is almost completed. What I am missing is the final expressions for every minterm. I'm just going to squeeze them beside the diagram, and that will be the solution for my question.